Dr. Niklas Jarvstrat is background material mechanics, metal fatigue, aerospace, other industries. And he is currently working on a Moonbase analog using an old school.
And let me see if I can share the screen then. Then I'll see if I can make the presentation appear there as well. There won't work. Yes, that was
There you go.
wrong screen. I will swap screen. You got my screen. That's okay.
Is it PowerPoint that you put it in?
That is PowerPoint indeed. I think I'll just swap to the other screen. No, wait, I swapped to PowerPoint rather there. That works.
There you go. All right, I'm gonna.
Yep, good. So, yes, I am working on Lunar settlement analog since a year and a half, or since 2 decades, depending on how you count. Bit over a decade ago, I was trying to do the same thing in an abandoned iron mine. That kind of didn't work because the iron mine was a difficult place to work at because of neighbors and regulations and other things. So hoping that an old schoolhouse is an easier place to be. And I'm calling this place Moonbase Lappträsk because it is located in Lappträsk in the north of Sweden. There, and that's what it looked like in March 2022 when I first arrived. It's an old wooden school building. Wood is certainly the wrong material to make a Moonbase out of, but the size tallies with the diameter of the Starship and also some mine boring equipment. But why do I want to build a Moonbase, and why the moon specifically? The reason for the moon is that it's the nearest place there are resources, and it doesn't really matter if we want to go someplace else. The important thing is still self-sufficiency. It's really pretty site independent. The resources vary, but what you need to do in order to achieve self-sufficiency is pretty much the same. So if it is this moon, the nearest moon, or some of the gas giants' moons, that's fine. You could use the same type of thinking on Mars with a bit more carbon dioxide. So you at least have carbon there. Ceres and other asteroids, you can even use it on Earth, a desert or underwater, etc. Actually, there is another presentation talking underwater settlements later in this conference. And why do I want to look at it making something completely self-sufficient? And I do want to make it completely self-sufficient, which means that I do need a permanently shadowed crater to supply nitrogen and oxygen and carbon, essentially. It avoids buy-make trade-offs. It also gives an infrastructure backbone. You can have commercial at additional cost, effectively, and you get psychological security for the settlers. You don't have to rely on another shipment coming from Earth. And also, a self-contained society is budget cut proof, and it's no recurring cost. Looking at most or all probably cost estimates for lunar settlements or any other space settlements, the largest budget cost is usually shipping people there, because you then have to ship them back again and then ship new people. But if you have a self-sufficient colony, you don't have anybody going back, which means that you have a much lower cost of shipping people there. So the ground rules for this effort is that you can use any equipment you like, but you have to make it replaceable. You don't have to have it in place to start with, or you can ship the first one, but you need to be able to make another one. It will be a base for a backwards technology roadmap. You're not looking at what do you have and how do you ship it. You're looking at where do we want to go and how do we make that happen, in what sequence do we get it. But I'm not going to start by doing the roadmap. I'm going to start by defining what you need for self-sufficiency. The roadmap itself comes later. There are plenty of resources on the moon. The first one you think of, well, you have thought about that earlier, obviously, everyone here, but that's oxygen. The moon is 44% oxygen, so that's plenty of that. It's also plenty metals, 10% iron, 9% aluminium, magnesium, titanium, 2%. Sounds a bit little, but it is pretty high, actually. Titanium is in low concentrations on Earth as well. There's also plenty non-metal minerals, silicon for wafers, calcium, NPK, plant nutrients, except the N there, which is nitrogen. So the stuff that's not available on the moon is mainly carbon, nitrogen, and hydrogen, which is in trace elements, really. But those are volatiles and probably at least available at deposits of the poles in permanent shelter regions. So what do you need to survive? Survival is the key. That's down to the right. I'm not sure you see my pointer. In order to do that, we need some sort of life support, farming, chemical processing, giving air, food, and water. We can't do farming and chemical processing without having something to process and something to grow food in. So we need to get stuff out of the rock and of the frozen mud at the poles, which we call mining, and then we have manufacture. I have kind of broken that down into, or grouped it rather, in 4 main parts, which fits into Ben's definition of frontier enabling, because I'm also looking at what can be done on site using on-site materials. So the habitat, sleeping, eating, cooking, meetings, exercise, so forth. That's where the humans are and where you live. Then you have a greenhouse, which is where you get the food from. It's also air and water recycling. I think I will put laundry there, not because it has to do with the greenhouse and growing stuff in the clothes, but because it is cleaning dirty stuff. It's a recycling of clothes. Recycling dirty clothes as clean clothes in much the same way as you recycle dirty air into clean air. There is also a last point of the greenhouse that I think is very important, that is as a source of scenery, which makes it part of the habitat effectively, because that's where the people will go instead of out. You won't go out on a trip on the moon because that's dangerous, and it is okay. It is what's it called? Magnificent desolation, so it is beautiful in its own way, but it's not a place where you will want to go for exercise and things. You might go sightseeing, but that's it. And you might go out for the mine, where is the part where you extract resources from the environment, which is air, water, metal, nutrients, and silicon from mining. And I have also lumped in energy generation there, which is also taking something from the environment, which is sunlight, and you're then delivering that as other forms of energy into the colony. And of course, supporting all of this, you have the factory where you make the things you need in the other three places. You need tools, you need equipment, you need cups and plates to eat from, and you need pipes and tubing and soil for the greenhouse. Soil might, to some extent, come directly from the mine. Now, this is a plan of the schoolhouse, and I've divided it into parts: the mine, the factory, greenhouse, and habitat in color-coded. And in the basement, which is the lower part here, you see that the bottom part will be the mine, obviously. The factory will be kind of spread out, and the habitat will take up most of the space. The north is up. The west part here is where I will be living. I'm currently converting that. The east part is the old school gym, which will be converted into auditorium and conference facility, with a bit of a moon surface outside. I think I'll skip the map. And the greenhouse is kind of interspersed with the habitat, because we want to be able to use whatever you grow as the outdoor of a moon colony. So, okay, I'm getting into technology readiness levels, which is something NASA, we probably all know about that. NASA invented it many years ago. The left side here is essentially the ESA, European Space Agency version of it. And on the right is the Moonbase Lappträsk version. So the first three technology readiness levels is that there is some proof of concept. And essentially what I want to put together is technology that works. So I'm not going to invent new technology. I'm going to pick technology that exists on Earth and works. So I assume that I always have technology readiness level 3 for anything I will apply, because it works on Earth. Then I have some levels of increasing complexity in that is where I will actually look at it, from trying out the technology, running actual equipment, testing the input and the output of each process or technology step, and then manufacturing the equipment needed, or at least to keep parts of the equipment needed within the system. And the end level that I'm going to reach is where the full system is reproduced. I have manufactured all the equipment that I need. And then, of course, technology readiness level 9 is when the actual system is proven in operational environment. That would be up and running on the moon. I'm obviously not going to do that here. So, four parts, and what they look like in the schoolhouse. There is an unfurnished room in the basement, which I called the mine from the start, because I found a piece of bedrock at the floor. I consider this to be technology readiness TRL3. There is no equipment in actual use yet. And my plans for coming year is to clear the debris and some soil, replace and sanitize dry rot. I found a dry rot infestment in that wall there, so that wall needs to be replaced and cleaned, essentially. I want to actually break this rock using simple materials. I ordered chisel and feathers and hammer. I do have a hammer. I have started looking at magnetic separation of regolith simulant, which seems to be working. There are part of it that is magnetic. Next step is to make iron from that. I started to look into photovoltaics, not as in manufacturing it, but to install it. That will not be in this room, obviously, but rather on this wall of the house. The factory, several rooms, also the same thing there. I haven't actually done anything. I do have a furnace. I want to connect and try that out in the year. It is a ceramic furnace. It goes to 1300 degrees. I can't melt iron, but I can do some other things, other materials. I can at least heat things. There is a carpentry workshop since it was used in school. I plan to update that to focus more on metal and stone. I think welding is a key part of any Moonbase, so I'm going to get a welding torch and start trying to use that for metal deposition, not just putting metal together, but adding metal by wire. Essentially a 3D printer, but a manual one. Study iron processing and investigate induction heating and make some things using the equipment I have. In the greenhouse, that's the part where I've actually done something. I consider that TRL 4. So something has been tried out on site. I am growing spinach. That's a piece of spinach, and this is a piece of pineapple. It's very simple and it's very rudimentary, and the plants aren't new. I don't yet have a consistent test program for them, but I intend to add control and monitoring of light, temperature, carbon dioxide, and nutrients. Monitoring nutrients, it's quite easy. You measure how much nutrients you put into the bucket. And then there is a pump to pump water through the system here. So it's a hydroponics facility. I do intend to run 28-day energy cycles and start by killing some spinach by using 14 days of darkness and 14 days of light. That should not be possible. And then start from having standard daytime light and nighttime terrestrial day and night. Just see and compare that with, say, half of that light during 14 days and a bit more during 14 days. I'm going to add more of these sets of equipment. This is a window that I've closed up. It's the window to the right here is what it looked like before I put in insulation to reduce the heat loss, and a plywood board, and put this one in. So this essentially is a growth station that will hopefully become nice and green and pretty, and kind of simulate a window where there is I have closed the window to make sure that it isn't a window. I intend to add fish, making it going from hydroponics to aquaponics, and more plant species. We can't just have spinach and pineapple. I want bananas as well. And then the habitat, I consider that TRL 5. I am here, so, and thus I am living using the system. Next level, I need to be using a system that is derived from resources as well. The photo top left is what it looks like today. I have placed chairs where I intend to make a conference facility, and the central part here is picture of the rendering of the 3D drawing of what I intended to look like when it's done, which shouldn't take that long, hopefully. This year I've spent a fair bit of time converting the part that is going to be a dwelling and repairing stuff, repairing the roof, repairing the stairs, making things, and also making organizations, the logistics and legalities of having Moonbase is a bit difficult at times. So plans is to quite soon be complete with the dwelling conversion, and then the next step is to apply for planning permission to convert the rest of it to Moonbase. And of course the planning authorities don't acknowledge a Moonbase as something you can do, so I have to split it up into a hotel and a conference facility and offices. I do intend to make sure you can sleep here so that you can participate in conferences. So I'm going to buy some beds and put them in, and converting the school auditorium. And that's essentially it. How am I for time?
You got 8 minutes.
Yeah, good. I'm fine there. If there are any questions.
I have a burning question.
Yeah.
When will we see banana trees?
Banana trees will take about a year after planting a cutting. The reason, well, there are two reasons I haven't started. The main one is that the ceilings are not high enough for banana trees. They become 6 to 8 meters. So in order to do that, I need to make a hole up to the top floor.
They don't make miniature banana trees, bonsai banana trees.
There are, you can't bonsai a banana tree because it isn't a tree. It's essentially a grass or a herb anyway. So you can't cut the branches because there are no branches. It's just one trunk.
Right. So Sengus asks, what type of soil are you using in your greenhouse? Are you using Lunar soil simulant?
At the moment, and for hydroponics, I'm using water and nutrients. And as for stabilizing the plants, you can see something yellow here. That's rock wool. Rock wool is quite, well, I haven't tried, but it seems to be quite easy to do from Lunar materials, because what you do is that you melt rock and you spin like cotton candy. You make thin threads of it.
Cool. And James asks, what is your source for plant information? Potatoes need a day and night cycle, but wheat can be grown using 24 hours of light.
Yeah, a good question. I'm happy for input on that one. I am, as you mentioned, I'm a mechanical engineer. I'm not that good at plants, so I'm happy for suggestions on how to start and what not to do.
Yeah, I mean, and like I was saying before, this is all stuff that people can do. You know, go do your own grow experiments. Let's put the information on Lunarpedia and, you know, get some stuff in the books.
Yeah, I'm happy to coordinate at least the parts that I'm doing here as well. If somebody wants to do it, I'm also happy for, as I said, for suggestions on what to do, because I do intend to start growing in sections. It's not readily visible on this picture, but the top shelf here has a standard LED fixture. No, it's not LED, it's fluorescent tubes fixture. The bottom one looks dark, but it's because the plant light, which is mainly ultraviolet, didn't catch on the camera. So it does have light, slightly less, unfortunately. I should use the same amount of energy to create light for the different settings.
Yeah, it'd be interesting. Be interesting to do experiments to see, you know, what wavelengths work best.
Yeah. Then again, there are also different ways of doing that. One way is to have solar simulants, or even a light tube for getting sunlight to the plants for the day part of the lunar cycle, right. And then have whatever is most effective in. I'm not sure if to call it wintering or nighting, or but to right. survive the lunar night.
Right.
And because that's might well be that you just want the plants to survive. It's fine if they don't really grow, but they need to be quick at uptake after getting more light in the morning.
Right. Yeah. One of the interesting things that people can work on is how are we going to make lighting on the moon? You know, yep. How are we going to make light bulbs or LEDs? You know.
Yeah. And I do think that since what you need for you need power, which is more difficult really than light, because you do have sunlight. So in order to make power, I think there are two different solutions for that. One is photovoltaics, and the other one is thermal engines. And if you're doing photovoltaics, that's semiconductors, and you dope them. And that's effectively the same, very similar to what you do in order to make LEDs.
Okay.
I don't have an ambition to start doing that in the first couple of years, but I will start looking at whether that's possible. I have started looking at it, and that's why I'm saying that, yeah, it doesn't seem completely impossible if you're satisfied with a bit less efficiency than you usually get.
Right. Let's see. Ulf asks, any thoughts on how to demonstrate the recycling of wastewater?
Yes.
Oh, hold on. We got an open mic. Let me take care of that. Okay.
Sorry, what?
I got it. It's fixed.
Okay. Yeah. So yeah, I have started thinking about it. I think there are regulatory issues about what you are allowed to do. So I need to investigate that as well. Then again, you have composting toilets and things like that. So that is actually possible. It should be possible to spread that once it's properly composted soil. You should be possible to spread that out in the living room and use it as nutrients for plants.
Yeah, I mean, there's different types of wastewater, so I guess it depends on where that water is coming from.
Now, I was thinking about the compost part of it, but
right.
Yeah, wastewater, yeah, depending on what you want to salvage from that, I think it is possible to just heat it. But again, it's not something I've studied in detail, but yes, it is a good question, and it's part of what will be needed.
Cool. Well, great presentation. Very informative. Looking forward to see what you do with it. Yeah. Can't wait to see you working on the mine. I want to see you down there with a sledgehammer and a chisel.
Hammer, chisel, and feathers.
Yep.
And feathers is not what you take from birds. It is wedges, essentially, that you use to split the rock.
Yep, it'll be interesting to watch that.
Yeah, I have ordered it, actually, so that will not be too long before I do that.
Cool. Well, thanks, Niklas. Appreciate that.
And I'll stop sharing and see if I can present somebody else. How do I stop sharing?
Marufa says, not sure it's a good idea to grow mango and pineapple on the moon. Takes a long time to grow them. Vegetables are good, though.
Yeah. I like mango, and eating mango, I got some seeds, so that's the reason.
There you go. That is self-reliance, using whatever you got.
Yeah. And that means I did pretty well on time there. Yes.
Yep. It's time for Victor.